what we are going to look at today, and what I want you to write on the top of this, what we are going to talk about is how to find the distance between 2 points. Okay, finding the distance between 2 points. And I want you to think about that for a second. In the real world, if you need to find the distance between 2 points, let's say I want to know the distance between me and the door, what would we do? The distance between me and the door, what would we do, guys? Measure it, right? We'd take out a ruler, or probably not a ruler, that's not very long, tape measure, right? And we'd measure it, okay? That's exactly how you find the distance between 2 points. You measure it. Now, on a graph, it's no different. You measure it. But there are certain ways that you measure it, okay? Let's look at example 1 here, and I'll show you what I mean by measure it. So the first thing that you have to be able to do, you must be able to graph these points, okay? So point A, we're going to start in the middle. That's where we always start. The first value, which is our x value, is -5. So we're going to go along the x-axis to -5. That would be this way. And then the y value is 1, so we're going to go up to 1. Boom, that right there, that is point A. Now point B, we're going to start in the middle, and this time on the x-axis we're going to go to 2. And then on the y-axis we'll go up to 1. Boom, that's point B. Now I'm going to go ahead and connect these. This right here, this symbol means segment. So here's a segment, a line segment right there. And what we're talking about is the distance between point A and point B. Now, if I get out a ruler and I measure it, I could measure it and that would give me the distance in probably centimeters or inches or something like that. That's not what I'm talking about here. I want to know on the graph, how far away are these 2 points? Now, suggestions. Anybody got any ideas? How exactly should I figure out the distance? Exactly, that's it. Because 1 square is 1 unit. Okay, they're counting by ones. So she says, I almost said her name, she says just count. She's exactly right. Okay, since this is just a horizontal line and it's going directly on top of another line, you can just count. So when you count these, you count the squares between them. So right here I've got 1, 2, 3, 4, 5, 6, 7. So there are 7 squares between A and B. That means segment AB is 7 units long. Units, blocks, whatever you want to say. You could just say 7, but it's 7 units long.
I have a question.
Okay.
Will you ever have a point where it's like in between 1 and 2? Like 1.5 or something?
Maybe. And we'll discuss what to do when that happens. I don't usually do that, but I could. Okay, so right here, I'll put down here, just count. It's that easy. You literally just count. Okay, so look at example 2. We're going to graph points M and N. So M is at 1, 4. That would be over 1 of 4. That is my M. N is at 1, -3. Boom. I'm going to connect them. Well, I'm not doing a very good job connecting. But that's just a straight up and down line. So, do you think we can just count? Again, just count the blocks between them. Now, whenever you count these, a common mistake, I want to zoom way in to do this. A common mistake I'm seeing kids do when they count is they start at M and they call that 1. Well, you haven't gone anywhere, right? So, you start here. This would be 1, 2, 3, 4, 5, 6, 7. Okay? So this segment right here is 7 units long. That is the distance between M and N. 7 whole units. Again, 7. Okay? All we had to do was just count. Now, can anyone see a problem that might arise with what we're doing?
It can go like in a different direction.
Exactly. Perfectly said. Right here, we're talking about just a horizontal line. That's easy to count. Here, we're talking about a vertical line. That's easy to count. She says, what if it goes in a different direction? And I think what she means by that is, what if we go like slanted at all? Not going to be as easy to count. Matter of fact, not even possible to count. Okay, so I want to show you what to do when that happens. It's not hard. but it's not quite as easy as just counting. So let's look at example 3. So I'm going to start by graphing point T. All right, so -2, that would be here, and then -3 would be there. So that's my T. And then point V is at 0, 3. Now, if my first number is 0, that means I don't go anywhere, right? And then on the y-axis, I go up to 3. All right, so that's V. Let me connect them. So yeah, we can't just count this, okay? Because from here to here, let me zoom way in again. All right. Focus one. From here straight up is 1, right? But from here over here is not 1. Okay, it just doesn't work like that. And then from here to here is not another 1. Only straight up or straight to the right or straight to the left can you do that. So there are actually a couple of different ways that I could find the distance here. There's one pretty complicated formula called the distance formula. I don't like it. I do not like it. As a math person, someone who is good at math and likes math, I don't like the distance formula. Okay, so let me show you a better method. What I'm going to do is I'm going to visualize a right triangle that starts at T and then it goes up to V, but it goes over 2 and then it goes up however far that is. What I have done is I have taken this and I've formed a right triangle out of it. Now let me show you why this is useful. Can I figure out this line segment's length? I can count that, right? How long is that segment down here? 2. 2 steps, 2 blocks, 2 whatever you want to call it, 2 units. Can I figure out the length of this one? Straight up and down?
Yeah.
Sure, I can count, right? 6, okay. Now what that allows me to do, I've got this right triangle. Here's my right angle. Ah, exactly. We learned that fancy Pythagorean theorem. Now that's a formula, but it's not near as complicated as the distance formula. I promise you that, okay? So what she said is this would be C. Yeah, I know how to do that. Let me zoom back out a little bit. Maybe a little bit more. Okay, so this one's going to be my C. These are going to be A and B. All we got to do is find C. So I'm going to say A is 2. And that would make B 6. Y'all remember what to do here, right? We just add those together. Honestly, you just type this in the calculator. 2 squared plus 6 squared. You can do it one step at a time, or you can type the whole thing in. That gave me 40. And what's the last thing we need to do? Square root it. Square root 40. And it looks like about 6.32. So that means that segment up there, let me scoot back up, from T to V is about, and I'm saying about because we did round it, it's about 6.32 units long from here to here. That's not so bad, is it? Okay, I want you guys to try, let me put this up here. TV is about 6.32 units long. I want you guys to try example 4, okay? So you're going to plot X, you're going to plot Y, you're going to connect them, and then see if you can find the distance between X and Y. All right, so again, if you plot your points wrong, you're going to get the wrong answer on this, okay? So you have to make sure we start slow, get your points where they belong. So X is at -3, +3. And then Y is at 1, 0. So my first number is 1. Go over to 1. My second number is 0. That means don't move. So right there. Back over to 0 here. Okay, so we're going to connect those. All right. So anytime you have some kind of diagonal line or slanted line, you have to draw in your triangle. Now, you can draw your triangle. I want y'all to see this. Either way is acceptable. I can go down and over, or I could go up and over. Either one's going to work, okay? So I'm just looking at it, I'm looking like I'm going to go down and over. So how long is this segment here? 3. How long is this one? 1, 2, 3, 4. Got to make sure you count correctly. And here's a helpful hint for you. You're always going to be finding C on this. Okay? Always. Because that's always going to be your slanted line. So a squared, I'm going to do 3. B squared, I'm going to do 4. When you add those together, you get 25. And then last thing, square root 5. So that means that little slanted line there, XY, is 5 units long. Yes?
As long as your C has to be bigger than your A and B, or else you're not doing it right.
Exactly. That's another good point. So because this one's C and because it's 5, it is bigger. Back to this one, we got 6.3. Is that bigger than the other two? Barely bigger than this one, but it is bigger.
Would you ever have to go a square?
You could, or it would actually be a rectangle, but it would just be like finishing this thing out. But it's going to give you the same numbers. Up here would be 4, and that would be 3. And it would still, this one would be C. So just get you a right triangle and you're okay. All right, again, I'm going to give you a couple of minutes here. I want you to do examples 5 and 6. The only difference here is I've got bigger graphs, but you're going to do them the same way. Okay, so let me go over these real quickly. Again, first thing, most important thing is to make sure you get your points correctly graphed. So -8, 3. Now these graphs are kind of weird because of where the numbers are, so it wouldn't hurt to count. -8 would be 1, 2, 3, 4, 5, 6, 7, 8. And then -3 would be 1, 2, 3 right here. And that is B. For P, we are at +3, -3. And remember, when you're finding the distance of a line segment or the distance between 2 points, your first option is to count if you can. If it is a flat horizontal line or a vertical line, you count. Okay, don't draw a triangle, just count. So right here, you're going to count from here to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that one is 11 units. Okay, and for example 6, we're going to go to 2, -7, and then 5, 1, 2, 3, 4, 5, 6. Okay, and then the distance between there. So if it's not a horizontal or a vertical line, you can't count it. So this is when we draw in a triangle, and it's very important. It has to be a right triangle to do the Pythagorean theorem. Has to be. So you either need to go straight over and straight up, or straight over and straight down. Has to. And you always want to follow along these grid lines. So I'm going to go over. I'm going to go over until I'm lined up with that one. And then straight down. So that's my right triangle. Right there's my angle. So I need to know this side. That's easy. That's just 3. And then here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Make sure you go all the way across. Okay, that one is 13. So to find my C, a squared plus b squared equals c squared. I'm going to add those up. I believe that is 178. And then square root it, which I don't have my calculator on me. Here we go. The square root of 178 is 13.34. So this segment is about 13.34 units long. Okay, again, I just want to repeat one more time. First thing, make sure you graph your points correctly. If you can count, count. If you cannot count because you've got a slanted line, that's whenever you draw your right triangle, count the 2 sides, and then you do the Pythagorean theorem, which we spent lots and lots of time doing, so we should all be good on that.